Hi students. Oh my, I see a wonderful typo here. January 258th. It kind of feels that way though. I might leave it for now. So we are going to continue to prove equivalence. This is one more strategy for us to try out. And we have the exact same learning goal. We can prove algebraically two algebraic expressions are equivalent. Remember, we are not solving. We are proving that both sides are exactly the same or equivalent. We'll still be trying to just choose one side to manipulate. One line equals one step. So we want to make sure to go at a slow pace and justify everything we do. Okay, so strategy number 4 is going to be multiply by 1. Which seems kind of silly because we're just multiplying by 1. What is that going to do for us? So let's take a look at this. Prove the two expressions are equal. I see two fractions on the left that are trying to be combined, but I know in order to combine, I need exactly the same values on the denominator. So we need equal denominators. Right now, this one has an x. This has an x times x minus 1. So what we can do here is we can multiply by a fancy number 1. X minus 1 over itself is just 1. In this way, we've not changed at all the value of that left side. We are going to change what it looks like. So this first step is going to look like this. 5 times x minus 1 over x times x minus 1. And we're going to repeat the right fraction exactly as is. And our reasoning for this is just to get from this to this. Our reason is we multiplied by 1. That's it. Okay, so now, and again, there's no perfect way to do this. I kind of feel like I would like to combine the fractions at this point. So I'm going to say 5 times this minus x squared all over that same denominator. And my reason here is just going to be subtract fractions. We just subtracted, that's all. The next thing I want to do, because again, we're trying to keep our eye, what are we trying to get to? So on the right side, we notice that it's just a sum and difference of terms. There is no, like we have this 5 times x minus 1 and x times x minus 1. So I think I would love to go ahead and use the distributive property. So we have 5x minus 5 minus x squared. I'm going to do the same on the bottom. And this is okay to do in one step because it's exactly the same reason. So I'm going to say that I use the distributive property. Okay, now we're really close to being done. And you're like, well, Mrs. Wojcik, it's exactly the same as the right, but the order is different. So I am going to rearrange the order to match exactly. Negative x squared plus 5x minus 5 over x squared minus x equals the exact same thing on the right. And the reason for this, and I kind of ran out of space here, but the reason for this, so there would have been a little swoop from that line to this line, and this is just the commutative property. And you can have a list of all the different types of reasons. You can have that written out so if you get a little stuck like, wait, what did I do? But commutative property means you can add and subtract in any order. You can rearrange the terms and you'll still get the same value. So that's what we did here. Instead of having this negative x squared at the end, subtracting, we're going to put it in the front and it means the exact same thing. So at this point, we have proved the left and right side are equivalent. Okay, so this is a you try, and I would definitely recommend you pause me and go ahead and try to do this problem. I'm going to keep going, so if you've already tried it, that's great. So for this one, I notice we have a 3x, and an x minus 4. Again, keeping our eye on the prize, this is what we want it to look like. We want it to look like a single fraction. And right now on the left side, I have two fractions. So what I'd like to do is combine them. In order to add or subtract fractions, we must have a common denominator. So I am going to go ahead and create that by multiplying by 1. So 8 times the quantity x plus 4 over 3x times the quantity x plus 4 plus, I'm just going to bring that fraction right on down. Okay, and then again, my reason, how did I make it look like this? I just multiply by 1. That's it. It's a fancy number 1. Anything over itself is 1. Okay, so from here, I can go ahead and combine. Some of you might say, you know what, I think I would actually distribute first, and that's fine. So I'm going to go ahead and do that for this one. And in that case, it really doesn't matter which one you do first, as long as you're doing one step and you're telling me what you do each line. So the justification here is I use the distributive property. Now from here, we're going to go ahead and we're going to add the two fractions. So I'm going to go ahead and say 8x plus 34. Actually, I'm not going to do that yet. I'm going to say plus 32 plus 2 over 3x. See, I almost squished two steps together. So right here, this is where we add the fractions. And now I'm going to combine like terms. So 8x plus 34 over 3x times x plus 4. And how did I get to this step? Oh, I combined like terms. Now we almost look like this. The numerator we match, denominator not so much. We're very close. So we're going to go ahead and use the distributive property. I leave the numerator alone, 3x squared plus 12x. And now I say, hey, this matches. So that's how we know we're finished. And a check mark. We can't forget that last reason. From here to here, we use distributive property. So you notice we used it at two different spots. That's totally fine. There is no perfect way to do these. So this one took more steps than I might have done it if I looked at it in a different way. I might have done the distributive property at the same time, but it doesn't matter. So you just make sure that every time you do a step, you are coming up with a justification, and it doesn't matter how many steps it takes you, okay, as long as it's one thing per step. Okay, now this is strategy 4 continued. We're still going to multiply by a fancy number 1. Now, this is a little crazy. This is called a complex fraction. So we have a fraction within a fraction. I'm going to again look to the left side. So I am going to suggest that we multiply by x over x, which really is just 1. So this is x times, and I'm going to show you what happens here, and hopefully this will make sense. We're multiplying numerator and denominator, okay, by x over x. The way we're doing this, right, we say numerator times numerator, denominator times denominator. Remember, x over x is really 1. So we didn't change the value, just what this looks like. So for reasoning here, again, multiply by 1. That's all we did. Now let's go ahead and use that distributive property and see what happens. So we have x plus, what's x times 1 over x? That's just 1. And in the denominator, we'd have x minus, what's x times 1 over x? 1. And now we match. So our reason here, we just did the distributive property. And now we're good to go. So what I looked at is you're trying to find out what will kill all the little fractions. And in this case, we only have a denominator of x. These will get messier. So there will be places where we need to be a little more creative. In this case, if I multiplied both numerator and denominator of this big fraction by x, it was able to kill off all those denominators that were something other than 1. So let's try another one. So here's one where it's going to get a little bit trickier. So you're going to first identify what are all my baby denominators within the big fraction, right? All the small fractions. So 9 in the numerator is just 9 over 1, so we don't really have to worry about that. But I do see this x and the 3x. So we want to say, what's the common denominator between those little denominators, x and 3x? And it would be 3x. Now watch what's going to happen when we multiply. Okay, so remember this is still just a fancy number 1 that we multiplied by. We get 27x over 3x, and I'm going to put this in parentheses, 9 over x plus 2 over 3x. Okay, so again, what do? We just multiply by 1. That's it. Okay. Now, let's look at what happens when we distribute. So the 27x we leave alone. 3x times 9 over x. Notice those x's are going to cancel. So we actually have, and I'm going to write this out, we have 27x over x plus we have 6x over 3x. And that is the distributive property. Okay, now from here, we would think, that would just be 1. That would just be 1. And then that would be 2. So we could look here and say, hey, now we know some things are going to cancel. So we reduce or make 1s, that's our reason, over 27 plus, let's see, the x's in both cases cancel. So we'd have 27 plus 2. Our reason here is we reduce or make 1s. And remember, if we make a 1, x over x, 27 times 1 is still 27. Okay, now we're going to go up here and we're going to go ahead and say 27x over 29, and ta-da, that equals what we were trying to get. And so what's our reason for this? So we could say we just used addition. If you said combine like terms, that would be fine too, absolutely. And now we've proved it. So last strategy, multiplying by 1, and it's going to obviously look different because we're trying to come up with a creative 1 that makes our life much easier, and then we're able to do this proof and just